So welcome to the video for solving polynomials, and in these notes we're going to need to recall a few things from previous lessons. First, the fundamental theorem of algebra, which if you recall says that the total number of complex zeros, which are real and imaginary, including multiplicity, right, that must equal the degree of your polynomial. And in Algebra 2, you learned the quadratic formula, which we can use whenever a quadratic trinomial does not factor to find irrational or imaginary zeros. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. And the a, b, and c, they come from standard form. So when you have a x squared plus bx plus c as your standard form quadratic trinomial, then the coefficients are the a, b, and c that you use in the quadratic formula to find the zeros. So in example 1, here we have a polynomial and a factor that are given. Our polynomial 2x cubed plus 3x squared minus 8x plus 3, and the factor that's given is x plus 3. So first we're going to divide using the given 0 to write this or rewrite this polynomial in completely factored form. And if x plus 3 is a factor, then the corresponding 0 is x equals negative 3. Since that's a linear divisor, I can use synthetic division. So I'm going to list my coefficients: 2x cubed, 3x squared, negative 8x, and then the constant is a positive 3. And when we do synthetic division, we bring down that first term and then multiply. 2 times negative 3 is negative 6. Then add 3 plus negative 6 is negative 3. Then we're going to multiply. Negative 3 times negative 3 is positive 9. And add negative 8 plus 9 is 1. Then multiply. 1 times negative 3 is negative 3. And add negative 3 plus 3 is 0. And 0 is the remainder, right? So the factor theorem and the remainder theorem together tell us then that the divisor times the quotient would be a way to represent the dividend, since x plus 3 is a factor. So this quotient, if this is our remainder, then the 1 is the constant, the negative 3 is the coefficient on x, and the 2 is a coefficient on x squared. So we could write that in factored form then as x plus 3 times the quantity 2x squared minus 3x plus 1. Okay, this is a quadratic trinomial, and in step 2 it says we're going to try to set each factor equal to 0 and solve for x. So this quadratic trinomial, if it factors further, would make that easier to do. So I'm going to look for factors of 2 that add to equal negative 3, and that would be negative 1 and negative 2. So then in my factor box, I'm going to put the first term in the first box, that's 2x squared. The last term, the constant, goes in the last box, that's a 1. And then the diagonal is going to get these factors that I got from the crisscross. So negative 1x and a negative 2x. Then I look for the greatest common factor going across each row and up and down each column. So 2x squared and negative x have an x in common. Then 2x squared and negative 2x have a 2x in common. Negative 2x and 1 have a 1, and negative 1x and 1 have a 1. Since my diagonal is negative, then each of these signs is going to be negative, and those would be the factors then of the quadratic trinomial. So x minus 1 and 2x minus 1. So now that it's completely factored, I can solve by setting each factor equal to 0 and solving for x. So x plus 3 equals 0, x minus 1 equals 0, 2x minus 1, oops, fix that. So 2x minus 1 equals 0. And then we have x equals negative 3, x equals positive 1, and x equals a positive 1/2. And those would be the three real zeros. Remember from the fundamental theorem of algebra, the number of zeros, including multiplicity, has to equal the degree. And our degree is a 3, and we have 3 real zeros, so we found them all.